Hello viewers, welcome to Code Liner Plus, and we are here after all the theory of the basics of the programming. So let us begin with our first program where we will see how to start programming in C language. Okay, I'm going to use the Turbo C3 for this. I'm not going to use the code block that most of the people use. Okay, I'm just going to put a download link for you. You can use it for Windows 10 or Mac, whatever you use. Okay, let's get started. I've already downloaded it, and here is my program set, and I'm going to just pump it up. Okay, let's start with this. Okay, so here we are into our Turbo C3, and what we're going to do is, first let me give you the overview of this whole console. Uh, on the top line, you get all your menu bars, plus the extended menu is at the bottom. Okay, so as you can see, to compile the program, you have given Alt and F9. You can directly compile it by pressing Alt and F9 key. And to run the program, you can use Control and F9 with that. So it will just first of all compile the program, and then it's going to run. And in this compilation, it will just compile, it won't run the program. So as I told you, the C program includes two sections. One is the preprocessor, and second is the code blocks. So what we're going to do is first we are going to call in some preprocessors for our program. As this program we are going to do is in the C language, so we are going to use two of the most important sets of header files, that is conio and stdio.h. So I'm going to tell you what the full form is. Include stdio. stdio stands for standard input and output. I hope I have mentioned it in my previous lectures of where I have taught you about the common header files that are present with the C. Okay, and apart from that, we're going to include conio.h. Okay, and the conio.h is the header file that throws the output on your console. That's your system, whatever you use. So, okay, next what we're going to use is we're going to use the data type int and main. The main function is the most important one where we run all our program and everything, just all of your code execute at that point of time only. Okay, now from the Conio header file, we're going to call in two things. First is CLRCR. This function, this is a function, okay. So this function basically clears the console or the output window from any previous outputs that are being present onto the console, because it does not create a new console every time when you run the program. Here in this Turbo C3, as per in the code block, it creates a new console output window where you don't have to use the CLR or CR command with that. So here in this program, we have to use it. Okay. Next, what we're going to do is we're going to just use the printf command, and under it we'll use double quotes. The double quotes are used to specify a string what we need to write into it. So all the code come, or not the code specifically, the string or the thing that you need to just put onto your output window comes between these double quotes. Okay, here I'll write this C. I will be programmer, and yeah, and line termination with a semicolon. Okay, after this, there is one short problem that if you run this program, it will not give you an output. And why is it so? It is because you haven't hold the screen. The console does not hold itself for the output. Okay, so in order to hold that screen for the output, you need to either initialize a return value or you use the getch. I prefer you use getch. It is much more efficient in working under conditions. Okay, I'll just show you what happens. So just let's compile it first. I'm pressing Alt and F9. Okay, and it gave me one warning that function should have a return value. We'll later know what functions are and what the return value should be. Okay, and now let's punch it in, and just don't worry about it about the warnings, because they don't actually create any problem with your program. They are just a reminder that this particular function set needs this kind of a structure, or it's just a predefined structure that has been initialized with it, that if it is not followed, it throws a warning. Okay, let's run the program. So have you seen that bit of glitch that came in? Yeah, exactly. This glitch actually resembles that when you run the program, the output screen didn't hold. Okay, so in order to hold the output screen, we're going to use getch and this. So this will hold the window unless a key is pressed. Okay, so now let's compile this program very well, and let's run this. So here we are. I'm a C programmer. So this is how you can just write down any of your strings into it and can publish it onto your program set. So this is how you just code on a basic level. Okay, so this is what all happens over here. Now let me show you one thing, that how these all things work all together. In that case, that you have made a program and it started. So how that whole compilation process works. So for that, I'm just going to pause this video for a second. Okay, so here we are. Let me tell you how your codes are executed. So when you first include your preprocessor and all the things, when you have written your codes and everything, the compilation of your program starts when you press Control and F9. Unless until the program is compiled, it's not going to run. Remember that. So what happens, and the execution process takes place after the compilation of the program, and during that process, first the lexic analyzer comes in. The lexical analyzer helps you to identify the symbols and the tokens. What have you initialized into it, like the percentage %d, percentage %s, percentage %c, whatever you have just given it. So all those things are being analyzed first, and after that the other things come, whether you have kept it all right or not. Okay, then the syntax analyzer comes in for all the syntax, like, for the printf or for the crr or any other thing, or any other function you have made, or the predefined functions you have used. The parameters are good, the parameters should be good as given like that, and they should not mismatch the factors, and all the things has to be appropriately according to the code source which have been given to you previously. Okay, so after the syntax analyzer, semantic analyzer comes in. What it does is that ensures that the declaration and the statement of the program are semantically correct. That means the meaning is clear. For example, if you write a equals to 1 plus 2, so the meaning is clear that you are adding two values and transferring the value back into a. Okay, but if you write a is equals to 1 is equals to 2 plus 3, the meaning will not be very much clear for the system to analyze that which thing has to be transferred first and which thing has to be calculated first. Similarly, for the function, if you are printf and you don't put your statement in the double quotes, then the semantic analyzer will not be able to analyze which part of the program is a variable and which part of the program is a statement. Okay, mostly then come the partial redundancy elimination or the pre-optimization, and it is a compiler optimization that eliminates the expression that are redundant or somewhat but not necessarily all parts of the program. Just for example, we have got a warning of return 0, that we have not used the return function, return value for the particular main function. So that optimization actually helps us to identify the warnings and the errors in the program. Next, the code is generated for the output window. The compiler just generates the code as your actual CPP file or the C file does not directly execute. It creates an optimized code that will be used in the assembler or the output into the program. After the code is generated, the post-optimization takes place. What it does is it creates an output for its own self on the first instance. Okay, and then it checks what all the assembler points and all the things that are going to be processed into your processors, and all of the things are apt to the mark and are apt has to be working accordingly as per the given direction. Okay, if it's not, it is going to throw you a runtime error. Okay, finally the assembler comes in, and assembler just put on all the basic instructions which is given by that particular function and by the code of user, what it has to perform, what the computer processor has to do into it, what the logic gates has to be used, which are other things has to be done. All those things come under this thing. Okay, after that, the one final step, there will be a linker and a loader. A linker combines of one or more object files and possibly some library codes, like we have used uh, the cdio.h and coding.h, that basically reads the files, and if it is not written properly, what error has to be thrown, if something is not up to that particular derivative set, what it has to be or what it does not have to be. Okay, and after that, loader reads the executable code into the memory and does some address translation, like which other part of the memory has to be done, or if you have initialized some variables, which part of those variables should occupy which memory block, and all of the things. Okay, and even they help to run the program, resulting in the program with the error message or both. And finally, ta-da, with a drum roll, execution of the file happens. That means the program runs and throw you that output which can into the console. This is how the program runs. And this is the way we are going to program all our things in our later project. One more thing I want to tell you, that when we are using all these things and creating a code here, I'm going to teach you how to do the competitive coding with all the questions and other things, and lots many things in the later videos. So, until then, thank you and goodbye.